going to take a look at some of the benefits of using InRoads to design a water system. What we have here is a overall view of Pickett Street, so I'm just going to zoom in here a little bit and show you what we have set up. Now where we're headed with this is to illustrate using InRoads features built into a surface, and those features represent the water system. One of the main things it gives us is quantities, so we can do quantity takeoff on the elements that are built into the surface, and also profile and cross-section display. So let's get started with that, and we'll also look at Storm and Sanitary for looking at the pipe systems in 3D as solid, so we can look for pipe conflicts, that type of information. So what I'm going to do is just rotate around my view here a little bit. This is drawn in 3D. And what I've done is I've taken some elements that were provided in a sample file, and I've got a water main here that is 6 inches, and you can see that it's level stratified. So that's on water utility main _ 6, representing 6 inches. We do have laterals on a separate level. And we also have some 8-inch and even 10-inch water mains on different levels as well. So what I'm going to do is I'm going to import those into a surface as features. And as I said, they are in here and they're in as 3D elements, so they're drawn at elevation. Now to get them in elevation, I draped them on the surface, lowered them 6 inches, and then I put a dip in the pipe up here. Oops. I put a dip in the pipe up here just so we could see what would happen if we have to bend that pipe. So at this point, they're 3D microstation graphics. So I'm just going to switch over to view number 1 is top view here. Not that it really matters. But here's the workflow. And actually, before I get in that, the driving thing to be able to quantify the elements that we create is to have styles built for them. If I go to the tools inside of InRoads here, and go to Style Manager, you'll see that I've built distinct features for the types of elements we want to import. So whether it's a 10, 8, 6-inch water main or even a 1-inch lateral, we do have pay items associated with those elements. If I double click a feature to bring it up, I can see that I've got the name, the description, the symbology that goes with it. But if I go down to surface feature, I can see that there's a pay item associated with that. We'll take a look at that in just a minute. If I go back to symbology, this ties into cross-section and profile view as well as plan. But if I hit edit, that's a shortcut to the named symbology being used. That can also be accessed through tools, name symbology. What I really want to look at is default point. Now if you can visualize a reference line crossing either a lateral or a water main, I want to be able to display an elliptical pipe. If I edit that point, what I've done is I've set up different name symbologies based on the different sizes of pipes that we might encounter. This happens to be the name symbology for a 10-inch pipe. What we're doing is we're saying I want to pull out a cell. That cell is built as a 1-inch diameter cell. So consequently, if we want a 10-inch pipe, we have to blow that up 10 times. Or if it's a 12-inch pipe, obviously we would need to blow that up 12 inches or 12 times. So that's what's driving the symbology for it. Now, if I come over to quantities and go to Pay Item Manager, you can also see that these are those pay items I've built for just the elements that we're going to import here. And that allows us to go, when we're done, to Tools, Quantity Manager, run that to quantify, and even assign prices to this and come up with a construction cost. We're not going to go that far, but that's the connectors having those pay items built. So I'm just going to close this for now. So what I want to do is I want to import the features or the microstation graphics into a surface as features, which gives them intelligence. Now I've got a DTM here that's existing ground for this site. We really don't need that. But what we're going to do is just move on to the File, Import, and into a surface. And we can create a surface name on the fly here. So I'm going to say Pickford Street Water System. And what I want to do is I am going to import stuff by level, or information by microstation level. And the first thing I'm going to import here is I want to get to the proposed utility water main, and let's get those laterals first. So that's what I'm going to take all these laterals that happen to be level stratified. They're at the correct elevation, so I'm going to use the elevation to use element elevations. Seed name, I'll just say this is lateral number 1, and it'll increment as it brings these in. Now the main thing, not main thing, but a key thing is the feature style assigned, which ties again into that pay item. So I want to make sure that I get that feature style that has the correct pay item associated with it. Now they need to be linear features or break lines in a DTM. They're really not part of a surface model, so we're going to exclude from triangulation. So I can apply. I get the message import complete. If I check my surface here, I can see that it imported 69 features, which happen to be those laterals. Now I just want to continue on, and instead of laterals, I want to get any water mains that happen to exist on this level, and I need to synchronize that with the feature style and the pay item I'm bringing it in. And we'll just say this is a main 6-inch, and we'll start with a name _1. Apply, we bring those in. Let's get anything that's 8-inch. Keep the naming convention going here. And I also have a 10-inch main. So let's take a look at what we've done. If I go to Surface, Feature, and Feature Properties, I can see that I've imported these laterals into a DTM. I also have 6-inch pipes. You can see the naming here where it incremented. I have 2 8-inch pipes and a 10-inch pipe as well. So now these are 3D features. They have unique names, they have the correct style, and consequently the correct pay item associated with them. So I can simply close this out, and let's take a look at how that comes into play. Now I could display these features back out in plan view if I wanted to, but I already have graphics there, so there's no real need for that. The other part that's coming into play here is here's my water main design, and here's the reference line alignment for this particular roadway. So obviously my water main's offset from the center line. I would like to see how the interaction in between the design roadway and where my laterals are and where my main water main is in relationship to my roadway surface. So we'll generate a profile. And I'm going to go to Evaluation, Profile, and I want to create a profile. And I want to see the existing ground, so I'm going to radio button that on. And I want to see the street or the water main system in there as well. So what I'm going to do is I'm going to profile down the alignment, the design center line. And what I'm going to do is I'm going to include projected features, which means it's going to project this water main, or it could project that water main onto the surface. In fact, I'm going to back off on that right now. I'm going to turn that off and just create a plain profile, and we'll update the profile to add those features. And the reason I want to do that is because of scale. Scale factors come into play. I don't want to exaggerate any more than's already configured the cells for those particular crossing points. And because I've got this set up, I should be good to be able to do that. So let's go ahead and turn those on. So I don't want to multiply the scale factor that's already been applied to those linear features that I'm crossing. So let's go ahead and include crossing and projected features. Now what that means is I'm profiling down the reference line. I want to project this water main onto the view that's going to show me existing ground at this location. And anything I cross will be any crossing laterals or water mains that I happen to cross in my profile view. So let's take a look and see what we get. And all it's doing is probably to retriangulate because I have added stuff into my surface. It has to be educated that I've done that. And I can see I've got existing ground up here. So that's my original surface. And if I come down here, I can see that it's projected that water main onto the location of the profile where the reference line is. Zoom in a little bit more. I can see it's also projected the points where it crossed the pipe. Now this cell was built so that the origin's at the middle, but it's also projected those laterals onto the profile as well. That may or may not be something I really want projected on. If I really don't want those projections, in fact this one over here was a projection of a lateral that would tie into a hydrant. So I'm just going to clean that up a little bit. I'm going to update my profile, and I just want to turn some stuff off. What I want to turn off is projected features. They exist in this water system DTM. And I really just don't want to see any of these laterals or even the water mains projected on. I just want to see where they cross. So, but I do want to leave on, well, we'll get rid of that. I do want to leave one on, and the one that I want to leave on is the main, the water main. So we'll just graphically identify it here. And we need to turn it back on. Got a little bit out of sync there. And that happened to be called main 6-inch. It happened to be the 8th one that I brought in. So now if I go back up to my profile view, I can see that's projected back on. Now, because it's an InRoads feature, it does not have any depth to it. We would have to use MicroStation to copy that parallel. And we are at a distortion factor of 10 here. So I've got an 8-inch main, and if I want to see what that looks like in graphics, and again, it's the center of the main, I would have to copy this graphic to get a representation of the top and the bottom of the pipe. So if I go ahead and copy that up 3.33 feet, remember we've got that 10-to-1 distortion there. I also need to copy it down an equal amount. And in fact, I could get rid of the center line representation. So now I've got the top and bottom of my 8-inch pipe. I can see where I cross a water main at the beginning. I can see where my laterals, my 1-inch laterals, tie into that pipe, and everything's dimensionally correct, and where I cross the 10-inch main at the end of Pickford Street, or the southeast corner. So that's profile. So that's giving us intelligence based on features. Same's true if we create cross sections. So if I go into create cross sections, same thing, we're going to go down the reference line. I want to see existing ground, but I also want to see the elements coming out of my water system. And anything I cross I want to see. I don't really need them 100 feet wide, or 100 feet on each side. We'll make them 100 feet wide altogether. And what I want to include is any crossing features, which will be the water main, or any laterals I happen to cross. So I'm just going to apply. We'll see what the graphics look like here. Create my cross sections. Get some screen real estate, and as I zoom in, I can see the existing ground, and I can also see the water main, in this case that 8-inch water main that falls a little bit left of my reference line. And I see that in all cross sections where it does cross that water main. So I can see where it is. I can also update this. If the water main changes, I can refresh or update the cross section or the profile, and this will automatically regenerate. So there's no measuring, scaling, drafting, and plotting manually on profiles or cross sections. Now that's great. The downside to it is that if I want to see or look for pipe conflicts or anything of that nature, I just can't see them, because InRoads features are a line. You don't have any volume to it. If I actually want to see 3D solids, I have to take a second step here, and it's actually an independent step. It's almost parallels what we just did, but we have to use Storm and Sanitary to create utilities out of these. And in order to do that, I'm just going to flip over to my Drainage tab, and I'm going to create a new drainage database. And we'll say this is Pickford Street water system. So now I have somewhere where I can populate or import what they call utilities. Now, I'm not really designing a storm and sanitary drainage system. What I'm doing is I'm going to go to utilities, and I want to create utilities. So it's similar to what we were doing before. We're going to load by level. We're going to define which level we're importing. So again, that's proposed water main, and we've got the 8-inch here, or 6-inch. Let's start there. Proposed utility water main 6-inch. I don't need to delete the graphics that are there, and I don't necessarily need to drape on a surface because it's already been taken care of. It's going to be utility number 1. Utility name here is gas. That's not necessarily what I want. I'm going to go to edit utility, and I'm going to take this one and I'm going to edit it, and I'm going to say this is my water system. And I can apply and close. So now I've got a choice here where I can say these are being imported as a water system. And up here I've decided I'm going to start with a 6-inch pipe, so let's get an appropriate feature style to go with that. So there's my 6-inch pipe, and I want it represented by a circle, and I want a circle that's 6 inches. Now when I import the graphics as a utility in Storm and Sanitary, I can define, am I importing the top of the pipe, the center of the pipe, or the bottom of the pipe? For this example, I had just set up center, so I'm going to stick with that, although I know that you design at the top of the pipe. We're just going to use that and go with it for right now. So I'm going to apply, and bear with me a second here as I import the rest of them, and you'll see what we're going to get here. And that happens to be an 8-inch pipe. Let's get the 10s. And also get the lateral here. And those are 1-inch. Now what that gives me is the visual check, and in order to see that I need to go to drainage. I want to view, and I want to view my drainage as solids. And again, I don't really have a drainage system here. What I'm really trying to do is just view the utilities here in 3D. When I apply, I get some new graphics on the screen. I need to zoom in to see them. I can see the line work for them. If I want to see them as a solid, I'm just going to change my microstation display. Currently it's wireframe. I'm just going to say smooth. So now that I have done that, I can start looking at that water system and see if I have any conflicts with other pipes that are there. And you can see I've imported a 6-inch that goes over to a hydrant there. If I scroll down here, and I can see the location where I'd put the dip in the pipe, assuming there was maybe a pipe conflict there or something like that. So that's two different steps that would have to be taken to see both 3D solids and to get the intelligence of the features in a surface so that they show up in cross-section, profile, and can be quantified with Quantity Manager. So two things, they're similar, but they're working in parallel to achieve a uniform result. The nice part about putting them in as a utility in a drainage database is these individual utilities, or pipes in this case, can be managed. We see the dimensions. They can be edited, they can be deleted, they can, we can review them, that type of information. They give us length, direction, slope. In fact, they can be edited using this dialog as well. But it also integrates nicely with streets and storm and sanitary, so we do get a complete 3D model where we can start looking for conflicts. So that's it for this session.